Alright, so here I'm going to go over some notes for dividing exponents with the same base. Okay. Um, First thing we need to do is remember that exponents is a way of repeated multiplication. If you need to, pause right now and go um, look at the notes for 8.8.8-1 notes, Introduction to Exponents. But for right now, I'm going to jump right in. So here, if you look at our screen, 8-03 notes for simplifying base divided by same base. Okay, so the first thing we're going to do, we're going to reduce fractions. If you forget how to reduce fractions, sorry, I'm going to go over different ways, but I want us to think of one specific way, or you might be learning a new way. But for right now, right here, your method, you probably would do something like this. You would take the fraction 8/12 and you divide by the same number on top and on the bottom. So we could think of what number can I divide 8 and 12 by, and you're probably thinking 2. And that's correct. So what I'm going to do is I'm going to divide both by 2. 2 divided by 2 is going to create a 1, okay? And whenever we divide any number by 1, okay, it's going to be the same number. So 8 divided by 2 is 4, and 12 divided by 2 is 6. So that's how we got 4/6. Now, you might be looking at that and say it's not fully reduced, and that's correct. What we want to do is we want to reduce it even more. So 4 and 6, what number can we divide both 4 and 6 by? And the answer is 2. We can divide both by 2. So there's another giant 1. And the answer is 2 divided by 3. Okay? And that's our reduced fraction. Now, what I'm going to teach you right now is we're going to learn the factoring method here, okay, and create giant 1s basically. So what we're going to do is we're going to take the fraction 8 divided by 12, but we're going to first factor out 8. So what we're going to do is we're going to think, what can we multiply to get 8? And one of the ways we could break up 8 is 4 times 2, or 2 times 4. Okay? And right here, 2 is a prime number, so that means that 2 we can't break down anymore, but we're going to look at the 4. So go ahead. I'm going to zoom in here. We're going to look at the 4. So how can we break up this 4? We could multiply 2 times 2 to get 4. Okay? So what we just did right now is we factored out 8. Okay? Now we're going to go down to 12. And we're going to break that up. So 12 we could multiply 3 times 4. 3 times 4. Okay? And 3 is a prime number, so we can't break that down anymore, but 4 we can break down to 2 times 2. Okay? What we just did was we broke down the big number 8 and the big number 12, and we created this tree, and we found out the smallest numbers we can multiply together to get that. So we have 2. So we're going to rewrite 8. We're going to rewrite it as 2 times 2 times 2 over, so 8 is the same thing as 2 times 2 times 2. If you think about 2 times 2 is 4, 4 times 2 is 8. So 2 times 2 times 2 is 8. And at the bottom, we're going to have 3 times 2 times 2. And those are the 3 factors that we got right here. 3 times 2 times 2. 3 times 2 is 6. 6 times 2 is 12. So 3 times 2 times 2. Okay, so what we did was we took 8 and 12 and we broke it up to smaller numbers. And now we can create giant 1s. So here, what we're going to do is we're going to take 2 divided by 2, create a 1, and 2 divided by 2, create a 1. And so now we can reduce, and now we know that it's going to equal 2/3, because 2 times 1 times 1 is 2, and 3 times 1 times 1 is 3. Okay? So this is the way we're going to be factoring. Here's a couple more examples. So we're going to use orange, green, and blue to represent these 3. Let's start with orange. So 10/25. Okay? And 10/25, we can see what can we break up 10 into. And 10 we can multiply 5 times 2. And that's as small as the numbers we'll get. And 25 we could break up to 5 times 5. Okay? So on the top, instead of writing 10, we're going to write 5 times 2 over 5 times 5. And now we're creating ones, so 5 divided by 5, okay? That's going to create a 1, so we can reduce this to equal 2/5. Let's take a look at 6 12s. 6 12s, so I'm going to go ahead and write that right here. 6 12s. And 6, we can break up to 2 times 3, or 3 times 2. And 12, we're going to break up to 3 times 4. Now, 3 and 4, 3 is broken down, but 4 we have to break down even more to 2 times 2. So that's those are our smallest numbers. So 6 I'm going to rewrite as 3 times 2. And on the bottom, I'm going to write 3 times 2 times 2. Okay? So what we're doing right now is we're creating factors, and we're going to create giant ones. So here, do you see any ones we can create right here? Can we create any ones? Hopefully you saw 3 over 3 and 2 over 2. Now, there are no numbers on top, so you need to recognize that it's 1 times 1. So on the top, we're going to have 1, and on the bottom, we're going to have 2. 1 times 1 is on top, and 1 times 1 times 2 is on bottom. So there we go. And if you look at 6 over 12, you might be able to recognize that 6 is half of 12. All right. 10 over 50, we're going to break up 10. 10, we can break up to 5 times 2. That's broken down. 50, we could do 5 times 10. And then 10, we have to break down to 2 times 5. Okay? So instead of writing 10, I'm going to write 5 times 2 over 50 is going to be 5 times 2 times 2. Oh, sorry, 5 times 2 times 5. And here we're going to create our ones. 5 over 5 creates a 1, and 2 over 2 creates a 1. And what we're left with is 1/5. Okay? So this is the concept of reducing using the giant one method or factoring method here. Okay? So now, what does that mean for us when we have exponents? Well, when we have exponents, it's kind of easy because we create our ones. So here, we need to remember that 2 to the third power, okay, is another way of writing 2 times 2 times 2. 2 is the base, so 2 is going to be the number that's multiplied, repeated multiplication, but it's going to be multiplied 3 different times. So 2 times 2 times 2. What do you think is going to be at the bottom? 6 times 6. Now, I wrote it a little bit further down just so that you can see what, I'm going to show you why, but we need to break up the 6's to smaller factors. 2 is already reduced, but 6, we need to break it up. So 6 can be broken up to 2 times 3, or 3 times 2. And for each 6, I'm going to write 3 times 2. So right here, this first 6 is represented by 3 times 2, and the second 6 is represented by 3 times 2. So that's the reason why I wrote it a little bit further down. And now we could create our ones. The 2's create ones right here. So on top, we're left with 2. And on the bottom, 3 times 3 is 9. Okay? Don't forget, you can always pause and try to see what's happening. Now, the second example, we need to expand again. So 2 to the third power, what's our base? 2. Too fast. And our exponent is 3, so that means 2 times 2 times 2 is going to be on top. What does that mean for the bottom, right? That means that the base is 4, and it's going to be multiplied 3 times. Now remember, we need to break down the 4's. So 4 can be, we can multiply 2 numbers, 2 times 2, 2 times 2, 2 times 2, and 2 times 2. So I'm going to rewrite this. 2 times 2 times 2 on top, over 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2 times 2. There's 6 of them. And then we're going to create our ones. And on top we have equals 1 over 2 times 2 times 2 is 8. Okay? So here are some examples of exponents. Now, What if there are variables? So example number 3, we have x to the 4th over x squared. So on the top, we're going to have x times x times x. That means that x is the base, and it's multiplied by itself 4 times. So x times x over x squared, so divided by x times x. Create our ones. Voila. We're left with x times x on top, which is going to be x squared over 1. That's our answer. Okay. Here, y to the 5th, I'm going to expand that, divided by y. So here, we need to create our ones. We can create 1, 1. And we get y times y times y over 1. Our answer is y to the 4th. Oh. Here you go. We have m to the 3rd power, so m times m times m, divided by m to the 5th, which is m times m times m times m times m. Create our ones. On top we have 1, on the bottom we have m squared. Okay? Here, on the top we're going to have 2x to the 6th. That means that there's going to be 6 x's multiplied. And on the bottom we're going to have x to the 7th. Create our ones. And we're left with 2 over x. Alright, so hopefully examples 3, 4, 5, and 6 were pretty simple. Example number 7 is a little bit tricky, okay? Because there are numbers and variables. So 16, we need to do what we did in the beginning of the lesson. We need to take 16 and break it up. Oh, first let's expand it. Sorry, we're going to get to that in just a second. So 16, x times x over 20, x to the 5th. I just expanded the variables. Now what we need to do is we need to take 16 and 20 and break it up just like we did before. Okay, so 16, we could break that up to 4 times 4. And 4 can be broken up to 2 times 2 and 2 times 2. 20, we could break it up to 4 times 5. And 4 can be broken up to 2 times 2. So here, instead of 16, I'm going to write 2 times 2 times 2 times 2. And then 2 x's, because those 2 x's are still there. And then on the bottom, instead of writing 20, I'm going to write 2 times 2 times 5 and the 5 x's. And those are from the left right there. Okay? And now we can create our ones, the 2's, the x's. And what we're going to be left with is 2 times 2 on top, which is 4. And on the bottom, we're going to have 5x to the 3rd. And that's reduced. All right, here's our last one. What we're going to do is first we're going to expand 35 times y, and then z times z times z times z. So we expanded the variables. On the bottom we have 15 y, z times z times z. Okay. Now we need to take our numbers and reduce them. So 35, we're going to break it up to 7 times 5. Those are both prime numbers. We can't multiply anything to get 7 except 7 times 1. And we can't multiply anything to get 5 except 5 times 1. So those two are good. 15, we're going to break up to 3 times 5. Those are also prime numbers. So that's as far as we can go. So now we're going to take 35. Instead of writing 35, we're going to write 7 times 5. And then y times y times y, z times, y times y times z times z times z times z. And you can see where that's coming from. And on the bottom, instead of writing 15, we're going to write 5 times 3 and y times z times z times z. Okay? Now, we can create our ones. We'll create our ones with the 5's, 1y, and 3 of the z's. So on top, we're going to be left with 7 times y. So you can see 7 times y times z over 3. Okay? All right. So that's the notes. Hopefully that makes sense. What I want you to do for your homework